Okay, Danny. Hi. So this is a quick intro video for you to start with its displacement tool. Just open MATLAB and find this function here. So displacement calculation, bathymetry. And in this case, it's version 1. Oops. So I'll just go through the steps for you here. First, type the name, of course, start the program, and then you see these boxes. They are labeled, and there's still a few things to do, as you may have seen already. But anyways, you start, of course, with loading the data. Then you can plot them in any way you like, or that's possible here. And if you've done that, you can then start tracing the fault and the offset features to determine the offsets. You can then also later do the backstepping and save. What I haven't done so far is fully implementing the save button. You'll see that in a moment. But for now, let's just start with loading. So what you basically do is press this button first. If you have a DM that's pretty has high, say, amount of noise, you can do some averaging, boxcar averaging. You can choose here how much you want to do. For the ones you've given me, they are pretty nice, so I don't have to do that. So let's just load. There's some here. I'll just take the first one and just ask gigabytes, as you know, and load it. Okay, that's it. Import it. So the next step is to just plot an overview plot of the whole scene that you have imported. And this is always a hill shade. And that hill shade can be specified if you want to. By that I mean you can change the azimuth and zenith. The values you put in here. So later on you will define a zoom box. You can also do the same things, but for now, if you want to do the overview, it also uses these values. So for example, I change now the azimuth, then just update. You'll see the plot changing. Also, for example, the z-factor, and just change it. You can see it. So now let's zoom in. The idea would be to identify a feature that you want to measure. This scene is a bit more tricky than other ones, but I think I want to reconstruct something in that area. So what you do then is you leave this box and go to the green one, to the next one, starting with the defining of a zoom box. And just 2 clicks, one side and the other. The idea here is to do this because maybe you have a data set that's 2 gigabytes large, and you don't want to do all the processing on these 2 gigabytes of data. So this allows you to zoom into the area that you actually want to study and measure. So it makes it basically quicker. So now I have my zoom box, and for this zoom box you can define a number of plotting feature configurations. Let's start over here. So this reads basically, as you can see here, drape the topography with transparency given here and color map, in that case topo, over the underlying hill shade, plot in that case with transparency 1 and another color map. In that case it uses this information given in here. Just plot it for now. So this is how it looks like. Okay. So as I said, you can now change things around to your liking. If you don't want to have hill shade, for example, you can then also use slope or openness as another feature. Let's say you want to do slope. Okay. You can then plot again, and you see it changed. What you can see is maybe that the color map is something you don't like. Another color map, but it looks inverted. So what you can do here is actually change the color map from inverted. So in that case, I want to invert the color map for the underlying, which is the slope. Here we go. It's still not very pretty, but in that case, I will just increase my maximum and minimum values for slope. In that case, decreasing the maximum. So let's see, make it, I don't know, 30 degrees maybe. That's a bit better. It's still not pretty, but I think it's good for now. What I most of the time do is I'm using contours. So here you can see for the given zoom that you used here, in here, you have the minimum and maximum elevations that are presented here. And then you can define an interval. Let's say 20 meters. Yeah, this is all meters, of course. and then plot again. And so here are the 20-meter contours. You can also do 10, of course, if you want to, and then just change the number and plot again and see the additional contours. If you want to get rid of them again, you just put some non-number in here, anything actually, and then enter, and then it says not used, so you can press again and it removes it again. Okay, so one other thing here to mention is this histogram of a lower. What I mean by that is you can look at the histogram of the data of this underlying here. So in that case it would be slope. So if you press the button, you see the histogram of the slopes that are in the data. That helps you a bit to stretch your color map properly. So in that case, say it goes from 0 to 30 because that was my maximum value here. Let's say make it maybe 0 to 20 or 15 because most of the data is actually there. And then plot the zoom again. That maybe looks a bit too saturated, but you know, you get the point. You can play around with it. Okay, let's say I'm just gonna go back to 30 now, and I will use contours. So the feature that I want to reconstruct here on the fault is this channel. I'm not exactly sure that it's matching, but I had looked before and it looks reasonably good. And also there are some other features that will align as well. So I felt reasonably good about this. So the way this is done now is, now that you have this map, is you can also increase and zoom in if you want to. That you start tracing the features. And here you can enter how many times you want to trace it. I don't want to waste too much time on the movie, so I just make it 5, which is plenty enough. And then you go through different steps. First you trace the fault, and then you trace the up fault and down fault sections of the displaced feature. Now let's just start with this. So each of them you will trace 5 times, because that's the number entered here. So, okay, start. And this is done by mouse click. So you just click on 2 points along the feature, 1 and 2. So this will be done 5 times now. You just outline the linear trace. There's a reason why the points always disappear, because I don't want you or anyone else to be biased by their own decisions. So the idea is to make these measurements more or less independent of each other. If you would leave the point, then you would of course look for them again. So now we have done the 5 times the trace of the fault. Now let's do the features. First 1, which I just call red because it's plotted by red dots, and I want to do this one. So left click with the mouse is again adding a point. Right click with the mouse is removing a point. So let's say I want to trace this one in here. I just go along the Thalweg. And the idea is to basically go all the way to the top of this channel, that you say up to this point the feature is still in pristine, so to speak, conditions. And then once it's not, you will do something else. So let's say I can see the feature all the way up to here, it's still fine. And then for the last one, you don't press, to finish, you don't press the mouse button, but you press F for fault. So what you do then is now from here to the fault, you will project into the fault. And that's important. So let's say I want to say that at this point, from here on, the channel should have been here. And then you press F. Then it projects the point to that area point. The next one. So indeed, did this a number of times. Let's say now I messed up and I'm just going really crazy here. As I said, you can just right click to remove them again. Okay, and then say project into the fault. So again, this is done 5 times. The distance between the points is not so important, really. The importance is the angle here at the position of the last ones, from here to here. If you put this point, this last one, the last point of the channel, close to the fault, then your range of your uncertainty is basically smaller. I'll explain that in a second, hopefully a bit better. Okay, good. This is done, and now let's do the other one. Same deal. I'm trying to be a bit quicker about it. Okay. Let's say it's supposed to be here. And maybe you will notice you don't have to actually click exactly at the fault of the position of the fault. Well, that was not so nice. The program will snap to it. So now the fault should be here. Maybe, I don't know, I can't see it. But I said it should be roughly here. And just notice where the square is going to appear. So you see, put it there. So it will snap to the closest position of the fault. Okay. Here we go. One more. Okay. Okay, one more. As you can see, I'm not really trying to be extremely precise here now. Just for the, just make it quick. So now you have traced these features. What features? Now you can see here, this box, it says vertical, use a vertical box plus minus 100 meters. That's basically looking at the trace, which you can't see right now. It grabs the DM data points within that box, in that range, to plot the profiles. So once you've done this here, you go to this button, plot the traced points. So you can see them now. You can see the longitudinal profiles here, these, and the actual, the ones you mapped. So I'm just going to zoom in quickly here. What you will notice, of course, is these gray lines. They change in orientation and position. And those are actually used later on for your PDF calculation. So what you do, or what the code does, is it's looking for the slope or the orientation from one point to the projection here. In this case, 5 times. So you have basically 5 different slopes on this side and 5 different slopes on this side. It gets the mean and standard deviation for them and uses those to sample from the PDF for this projection. So it computes from these the center point of these lines and then rotates basically with that given range. So one thing we still need to do now is for the longitudinal profiles to trace these here. Okay, let's do this. First the red one, also 5 times. So what do you think is... okay, so I think that's roughly the way it should have been prior to all the earthquakes. Done, now the other one. Okay. Oops, that was not so nice. Okay, done. So now you can, it's basically everything is done. Now you can plot the PDFs. That's shown here. So this one is vertical displacement. This one is horizontal displacement. And this is just the PDF width, the slope in that case, how much it varied. So you can see this was the fault, and these are the 2 channels that he traced, or that I traced. And you can see how much variation there was actually in here. The blue one has quite a bit of variability because of this one feature that was really off. But again, you can now see the displacement values that you measured. And I'm not saying that this is perfectly done now because I was just quick. But the way you can do it then is to take these values, these offset values. Oh, by the way, you see the PDFs here. These bars are 2 sigma. They're used later on for some automated saving. Anyways, but let's take this value here. It's about 900 meters. Let's make it 910. And the vertical was 60, roughly. Okay, so you can then backslip the model. Okay. So that's the result of the backslipping. Here. Oops. And then I'm just doing this now for visual inspection to see, yep, that feature really was, that looks good now. It really aligns nicely. Let's see. You can see maybe some other features also aligned. Like this one looks pretty good here, if I'm not mistaken. No, it's actually not right. That's not correct. But anyways, I guess you do get the point here on this one. So once you say, okay, I'm happy with this reconstructions, that the tree tracing was good, you can then start saving. As I said, it's not fully implemented yet. Oops, not fully implemented yet. But what you would do is simply just press the button for now. And what it will do is create a number of images. So here we go. Almost done. I think that's it. Yep. So now I had the name hardwired, which is blah, and so it gives you the reconstructed DEMs. It gives you the original one, it gives you the one with your tracing, and it gives you the reconstructions, the different combinations. That's all found here then in your folder. It's quite a bit of files. In the end, the idea is to have these put into a website where all of the data are presented at the same time. Okay, what else? Nope. Ash was going here. Okay, so that's basically it. I think I messed this number up, but oh no, that was because of never mind, because of the sigmas. That number changed. I think that's it for now. It would be best if you have a look at the tool and just give it a try if it works for you. If you have any questions or need anything changed, let me know, and I will do that. Okay, bye-bye.